Welcome to Character Explorations, a podcast production of the Wendt Center for Character Education at the University of Dubuque. I'm Annalee Ward, the director of the Wendt Center. Our guest today is Mauss, Associate Professor of Computer Studies. She's the author of the article, Stepping Over the Brink into Artificial Intelligence. And this article is available online at dbq.edu/WENDT. Welcome, Ann. As we think about the issue of this journal, Character and Transitions, I'm wondering why you chose to write about the algorithms of artificial intelligence. What does that have to do with transitions?
In my mind, the reason I focused on algorithms is they are the backbone of computers. And we are transitioning, meaning our culture is transitioning more and more every day to having computers do many of our decision-making processes. We talk about data analytics, we talk about artificial intelligence in the sense of self-driving cars and other types of issues where computers are doing decision-making process for us. And so for me, that is a transition in a sense that normally we would take the data that a computer would gather, but then we would look and find the correlations. We would look and find the decisions, such as maps. They could give us a map, but we would look at the different routes and we would decide on what route we would take. So when we think about GPS systems now, is they're telling us what route to take. And to me, that is giving up or ceding our decision-making process to the computer.
Okay. You mentioned in the article an example of the use of maps. Would you share that with us?
In the article, I was citing a story that ran a few years ago out of the United Kingdom, where a gentleman was following his map app, his GPS app, and he was going to a place that he had never been before. And so he was trusting this app to get him to his destination. What happened when he did that was, for some reason, the computer app that he was using had noticed it was basically a cow trail that was a road. And so told him to take this cow trail, and he was following it, not even noticing that it's becoming, more bumpy and rocky and not looking like a road, until he got to the end where, fortunately for him, there was this big fence, because had he continued to drive, that fence was keeping him from going off like a 100-foot drop. So this is where someone is just unthinking or unknowingly trusting something to do what they want it to do, and it's not giving them the right answer.
We've all heard these kinds of examples, and they're terrifying, but yet we do want to trust these things. We want our maps. We need our maps. We've used them for getting from here to there all the time now. So what is at the heart of the computer's decision making?
They're called algorithms. So algorithms, the basic definition of an algorithm is logic. Okay, so when I teach my students intro to programming, we spend in the very first semester, we spend the first 4 weeks just dealing with logic and algorithms and how to map out the way the computer is going to understand, because computers are very black and white. I tell my students, think of talking to a 3-year-old and how a 3-year-old, if you're telling a 3-year-old like to go get your shoes and put them on, sometimes they don't do it the way you ask them to do it because they are interpreting it differently. And that's kind of like what a computer would be. They don't understand. We have such nuances and we see many different shades, and we process things without even realizing the number of steps that we have to go through when we're making a decision, but we have to tell the computer all of those steps. And so in machine learning algorithms, which are the underpinning of artificial intelligence, we're allowing the computer to learn on itself. We're not telling the computer, take this step, this step, this step. What we're doing is we're giving it a set of parameters, and it goes out and just starts by trial and error learning things, and it comes up with its own answers.
How does a computer learn?
They learn, and in the book I kind of give you the example of like how you teach a dog. So in the article, I said I teach my dog to sit and stay, and I use hand gestures to do that. The dog eventually learns which hand gesture means what by the rewards I give it to her. So if she sits when I tell her to sit, I give her a reward. If she doesn't sit when I tell her to sit, she doesn't get the reward. And she eventually, very quickly, learned that means sit, that means stay. That's kind of how machine learning algorithms do, is the programmers will give proper, like correct feedback when it learns properly, and then so that it will continue along a path. Sometimes it will take it into a direction that not even the programmers had envisioned, and that's where we get some problems, is that the computer just starts going off on its own thinking it's getting positive feedback when in essence it's not.
You talk about it almost as if it's alive, thinking that it's giving.
It is. I wouldn't say it's alive, but it is thinking on its own, because it's been programmed to say, we call them if structures, selection structures. Well, if this condition exists, then do this, otherwise do this. And those are, it's a very simplistic approach to what they do. But that's basically kind of what the computer is doing. It's saying, oh, okay, if I do this, then I do this, and then I can do this, and it just kind of goes down its own rabbit hole to bring back what it thinks is the right answer.
Okay. So if I understand you right, then a computer is given information, data of some sort, or it's put in by programmers,
yes,
by people.
Yes.
And the programmers give it the feedback.
Yes. Or what happens in a lot of these machine learning algorithms now it's not the programmers per se giving them the feedback. What it is, it's the data that's giving them the feedback. An example would be, a lot of times they will use the Microsoft Tay, which was a foray that Microsoft went to have. It was a chatbot, so that people could, it would act like a teenage girl, and people could talk to it, and it would act like a human. And so what it was doing is they gave a bunch of information or data from like Twitter and Facebook and all of these kind of conversations that it was, and it had a learn algorithm implied. And so what was happening was internet trolls were able to figure out how that learn mechanism was going with Tay, and they were able to give it the feedback that it thought was positive to the point where they were able to get this chatbot to start, talking with racial slurs and just really bad language. And so they were able to teach it what it thought was correct by hijacking the positive feedback algorithm that was in there. So
what happened?
They took it down within a matter of hours and had to reprogram that learning mechanism. So again, it was the programmers that developed the learning mechanism, and it was great if you gave it a bunch of positive data and it would learn the positive data. But what was happening is there was negative data that it was learning from, so therefore it learned negative behaviors.
Would this data, this kind of shaping positive or negative data, be an example of what you call a sentiment lexicon?
Yes, that is a sentiment lexicon.
Okay.
So the lexicon is taking the words in context. So, we have all these different words, but when they are used in context is how you learn if it's a positive word or a negative word. So there was an experiment done where someone was learning voice recognition software, and they were using different lexicons, and it's basically how you can create a racist algorithm. And they were giving data just from the internet, and they were able to, because of the context around it, the software was learning that this was okay language to use. And so simple things like, if they were talking about going to an Italian restaurant or to a Mexican restaurant, the Italian restaurant had like a neutral association with it, but the Mexican restaurant actually had a negative association with it because of the word Mexican in there. And because there's been so much, negative racial association on the internet from using the word Mexican, that's how the algorithm learned that would be a negative response.
So it sounds like where the computer gets its data really matters.
Yes, it does.
How or what kinds of ways can a programmer ensure that its data is appropriate? Or can someone ensure?
They would have to really kind of clean the data up. So right now, what a lot of places are doing is they just go out to the internet because it has a vast amount of data, so that it allows the theory is you have this vast amount of data, and therefore you would get a widespread of different lexicons and different ways of learning. So therefore you're opening up and being able to make the correlations very quickly. The problem is with the way the rhetoric is on our social media, it's learning human behaviors that are not necessarily the human behaviors we want to learn. And part of that is, I think people, when they're anonymous on the internet, will behave differently than if they have to be accountable for what they do and say. And so therefore you're having this reinforcement of negativity.
There's one more example that you mentioned that I think is important for us to understand why this is such a problem. You talk about it in the criminal justice system. How are algorithms used there?
So I talk about a particular piece of software called Compass, and that has been used in the criminal justice systems across states for many years. And basically what that software was developed to do was to help judges supposedly independently look at each criminal and judge their ability to reoffend, and therefore it would bring, if they had a higher degree of reoffense, then they would get a harsher sentence. So what was happening is they were using data from the criminal justice system, which means that we already have a systemic bias, racial bias, to our offenders in our system in itself. So they were looking at that, and what it was doing is it had a racial bias, and it would say that a Black person, even though their offense may have been, if you looked at it, they were young, like 16, 17 years old. It was something that was innocuous, stealing a bike, and then they gave it up. That person was judged more harshly than a person that was a white male that had a record, meaning that this person had done similar behavior before. So the Black woman that had the lesser, if you looked at it, a lesser offense, was given a harsher sentence than the white man. And this is where I'm saying that the judge is thinking that this system is unbiased because it's not looking at, they think that it's a computer not looking at race, but in essence it is because of the data that it was fed, which was from our own criminal justice system, which was skewed. And so that kind of leads into what I talk about in the article and what I tell my students about garbage in, garbage out. So garbage means that if you have skewed, unreliable, or biased data to begin with, then the only kind of information you can get out of the system is going to be skewed and biased.
It's troubling that we don't know who's using what data and how good it is.
Mm-hmm.
I'm struck by something that ethicist Shannon Valor said.
Mm-hmm.
She says the 21st century decisions on how to live well, that is about ethics, are not simply moral choices. They are techno-moral choices, for they depend on the evolving affordances of the technological systems that we rely upon to support and to mediate our lives in ways and to degrees never before witnessed. You, along with Valor, call us to respond by emphasizing and by growing in virtue. How can Aristotle help us think about this? How might concern for context and transparency mitigate the problems? Can you give us some hope here?
Yeah, I think we can. So we talk about virtue ethics, and building a better future. And we look about the two issues of virtue ethics that I highlight are prudence and justice. And prudence is making judgments based on practical wisdom, and justice is recognizing what is good for the community and taking the course of action that reflects it. And I think when we're talking about making justice based on practical wisdom, I think what I mean by that is that we have to look at and be very conscious of the data that we're using to feed to these algorithms. And as a community, as a user of computers, I think we need to be more aware of how those systems are making those decisions. And I do talk about a concept of a black box, meaning that how those computers are making the decisions are not necessarily available to everybody because they are considered proprietary, meaning that the companies that develop them own that, and that it's like technological property, intellectual property, and that you can't see it. And so this black box means there's something that's happening inside it, and we're getting stuff out of it, but we don't know the mechanism. And that is part of the issue, is that we need to be aware and question whether, does this make sense? Using our own judgment and using our own sense of justice to say, yes, I'm getting this answer, but is it really correct? Should I look at a different, like a second opinion,
right,
on what we should do with this? And the biggest problem is if lots of companies are not willing to share that intellectual property. And so that leaves us at a significant disadvantage.
So is there a role for regulation?
Yes. What Elon Musk has said, that this is the most existential crisis that we are facing as humans are in the world today. And I agree with him that democratizing artificial intelligence is the way to go, because we need to have some type of regulation where we can look at those algorithms, look at the data that they're using, and decide whether or not it is being done with justice and in mind.
Anne, thank you for helping us to better understand how these algorithms work in computerized decision making, and for the challenge to encourage one another to pursue ethical practices and virtuous lives, even as we try to foster better artificial intelligence. Our guest today has been Ann Mauss, Associate Professor of Computer Studies, and I'm Annalee Ward for Character Explorations from the Wendt Center for Character Education at the University of Dubuque.